In August 2024, Saudi Arabia burned 814,000 barrels of crude a day, not to sell it, inside its own power stations. That is about 9% of everything the kingdom pumped that month, consumed at home. The world's largest crude exporter has one customer it cannot turn away, and that customer is the far end of its own grid. That number has a season. On a summer weekday at 1 in the afternoon, Saudi demand runs about 52 gigawatts. The same hour in winter is 26.5. The system roughly doubles and then halves again. Air conditioning takes about 70% of the electricity Saudi buildings use. On Enerdata's numbers, the highest share of any country measured. Cooling does not burn all 814,000 barrels. It is the reason the number has a summer. The physical reason has a name that sounds like laboratory equipment: wet bulb temperature. Wrap a thermometer in wet cloth, spin it through the air, and read whatever evaporation can still cool. For years, the number that mattered was 35 degrees, a theoretical ceiling, calculated rather than measured, for a healthy adult at rest, in shade, with water and moving air. Almost nobody lives like that. Then Penn State put people in a chamber. Vaselio and colleagues found the real limit for young, healthy adults doing almost nothing was closer to 31 degrees wet bulb. 4 degrees below the theory, in the fittest group you can recruit. Colin Raymond's team went through the station records. Between 1979 and 2017, wet bulb readings of 31 degrees turned up around 1,000 times worldwide, and the frequency of extreme heat and humidity roughly doubled. The Gulf is the densest cluster on the map. Long before anyone reaches a survival limit, they simply stop going outside. That is the moment a physiological threshold becomes an electricity problem. The Gulf crossed it decades ago and has been paying for it ever since. What it costs to stay habitable is a public number, published monthly. JODI's burn figures, Aramco's gas output, fuel oil imports, and an agreement signed 5 days ago. Across June to September 2025, Saudi Arabia burned an average of 593,500 barrels of crude a day in its power stations. Counting fuel oil and gas oil as well, total liquids for power approach 1 million. The strain has a schedule. From May to September, Saudi peak demand sits between 11 in the morning and 5 in the afternoon. Remember that window. Desalination is the other big load. Its total energy input has been put near 300,000 barrels of oil equivalent a day. That is an energy equivalence measure, not 300,000 physical barrels, and it also takes around 6% of national electricity. On the 23rd of July, Brent crossed $100 after Houthi strikes on Saudi tankers. Valued at that round number, the crude burn alone is about $1.8 billion a month. Gross opportunity value, not fiscal loss. Cooling is not a cost line in the Saudi budget. It is a subtraction from the revenue line, and it lands in the months when domestic demand is least willing to bend. In our own model, that distinction moves the answer. Saudi fiscal distress by 2040 is a 4% tail on a budget basis break-even, and 73% if the whole Vision 2030 program counts. Riyadh has known this for longer than anyone watching. The liquid fuels displacement program is designed to take 1 million barrels a day out of domestic oil use by 2030. Jafurah, the largest shale gas development outside the United States, began producing in December 2025 on more than $100 billion of investment. Rystad expects it to displace up to 350,000 barrels a day of crude burn by 2030. Saudi solar capacity went from about 4.7 gigawatts at the end of 2024 to roughly 12.5 a year later. And it is working. Oil burned for power fell about 270,000 barrels a day in June and July 2025, with cooling degree days almost flat against the year before. That drop was structural, not weather. The IEA now rates Saudi power plant fuel less than half as responsive to cooling demand as it was between 2010 and 2016. That is the sentence a Saudi planner would want quoted. The next three are the ones they would not. Gas output slipped to 10.5 billion cubic feet a day in the first quarter of 2026, down from 10.7. April fuel oil imports hit 360,000 barrels a day, up 86% on the year. Kepler puts the big gas-fired conversions in 2027 and 2028. Rystad's central case for this summer is 540 to 550,000 barrels a day. Its disruption case breaches 1 million. The fix is real, and it is not finished. That is the first clock. It runs from now to 2030, and it is wound by gas, sunlight, efficiency, and, when those fall short, imported fuel oil. There is no reactor anywhere in it. Which brings us to last Wednesday. On the 22nd of July, Washington and Riyadh signed a 30-year framework for civil nuclear cooperation subject to congressional review. A day later, Donald Trump said it would only proceed if Saudi Arabia normalized relations with Israel, a condition absent from the announced text. Nothing was canceled. The path stopped being clear. Almost every explanation published since has been about Iran. The energy case is older, and nobody is making it. The 2010 royal decree that created KA Care says the program is essential, and, I am quoting, to meet the kingdom's growing requirements for energy to generate electricity, produce desalinated water, and reduce reliance on depleting hydrocarbon resources. Which is the cooling argument made by the Saudi government in 2010. It read as a yes to me, too, until I looked at when a reactor could actually exist. No Saudi reactor has been ordered. The Duaihin site license was granted in March 2023, and the tender is still open. Barakah, next door in the UAE, took 11 years from contract to commercial operation. And Barakah is the optimistic regional benchmark, not a Saudi forecast. Which does not mean nuclear arrives too late. It means nuclear cannot be the instrument behind the 2030 promise. That 1 million barrels gets displaced by gas, solar, and efficiency, or not at all. Reactors belong to a second clock, a bigger, hotter, more electrified one. More desalination, more industry, data centers that did not exist when this program was written, and less appetite for burning gas either. In October 2024, Colin Raymond, Tom Matthews, and Cascade Tucholsky published something that should be better known. Along the southern Gulf Coast, the most dangerous humid heat does not arrive in the afternoon. It arrives after dark. Around 8 in the evening over the water, around midnight on the coast of the UAE. Sea breezes carry moist marine air inland all afternoon, and the humidity sits there through the night. But that is when people are in danger, not when the grid is. Remember the window. Saudi demand peaks between 11 and 5 May to September, which is, awkwardly for the nuclear case, almost exactly when solar is at its best. Nighttime load still has to be served, and firm low carbon output is a genuine argument for reactors. It is not a decisive one. Gas, batteries, thermal storage, and the Gulf Interconnector are all bidding for that job. Reactors can also make power and water together. The Korean smart design KA Care bought into pairs about 90 megawatts with 40,000 cubic meters of water a day. Whether that water beats modern reverse osmosis depends entirely on financing, none of which requires enriching uranium. The UAE runs 4 reactors at Baraka on imported fuel. It signed away enrichment and reprocessing to get them, and it accepted the IAEA's additional protocol. Saudi Arabia has refused that package for years. Part of the reason is not in dispute. In 2018, Mohammed bin Salman said Saudi Arabia does not want a nuclear bomb, but that without a doubt, if Iran developed one, we will follow suit as soon as possible. The July framework splits along exactly that seam. A 2-year joint study on whether Saudi Arabia enriches at all. On Time's account of the terms, a 10-year bar if Washington ends up saying no. And, per Al Jazeera, Riyadh declining the additional protocol. Imported fuel runs an air conditioner just as well. So keeping enrichment negotiable is not a cooling decision. It buys leverage over Washington, an industrial base, the standing of a sovereign, and the option of not ending up behind Iran. So the energy case and the strategic hedge were never rival explanations. They are 2 functions of one program on different clocks. Cooling explains why Riyadh wants reactors. It explains nothing at all about why Riyadh wants the fuel cycle. Our own framework treats this as a monitored channel, not a modeled one. We have the mechanism and the meter, not a probability. The meter is JODI's monthly burn figures for Saudi Arabia and Iraq, June through September. Back to August 2024 and the 814,000 barrels. They did not all go to air conditioning, but the shape of that number, a trough in February and a spike every August, is what a country that survives indoors looks like. The cooling bill arrives every August. The reactors, if they are built at all, arrive in the middle of the next decade. Roughly 10 summers in between, paid for in gas, in sunlight, and in bought-back fuel oil. The number to watch was never the deal. It is the August burn.